Oh, okay. Okay. Hi, everyone. Yeah, so I'm Zayne. First of all, like, thanks to NUS Hackers for inviting me. Yeah, it was very impromptu. Like, I got a text from Darren last week when I sent my very first message in the NUS Hackers group chat. But yeah, this is like just a brief summary about who I am. So recently, I founded this company called Hacktron AI. We've been going for around 6 months so far. Previously, I was a freelance pen tester at Core 53. I did a bunch of CTFs back in 2022 and 2023. I did some security research, found some vulnerabilities in like a bunch of HTTP servers. I was like weirdly obsessed with HTTP servers at some point. And previously, I had some stints at TikTok and OGP. Um, but yeah, I guess like in this talk, like there's like two sections. Like the first part, I'm gonna talk about hacking AI agents. So like hacking in the sense of like more like security hacking, like sort of white hat hacking. And so like that's just to sort of illustrate the thought process of like what I guess like hackers think about when they try to find vulnerabilities in systems. So a lot of like sort of a lot of people would like sort of in their marketing like babble say that, oh, like you know, like AI security is like very different from like traditional software security. But I think like that's kind of not really true. So like I think like the classic abstract problems are, you know, like still there. So this is a quote from Andre Kapati, who said like the hottest new programming language is English. Which kind of, I mean, like if you think about it, previously before LLMs, like all of the apps that people would write are like largely like deterministic, and then like sort of the wave of like ChatGPT wrappers came along, and then like people started replacing parts of their app with like AI and like LLMs. And so like if you think about it, like you are sort of programming in English by giving the LLM a prompt. And so like now this text that you are giving the LLM sort of becomes code in a way. And so like you have the same fatal flaw as any like injection vulnerabilities that exist in traditional software, like cross-site scripting and SQL injections. Like these are all, at the end of the day, injection vulnerabilities, which means that you are mixing untrusted data with some form of code. And so in the same way, like when you think about like even like the most basic sort of LLM vulnerability, like prompt injection, like you are mixing user input with the prompt that you are giving the LLM. And so like to illustrate my point, like we will talk about like this vulnerability that we found in Perplexity's new Comet browser. So this was like disclosed to them a month ago, and like they've fixed it so far, which is why I'm allowed to talk about it. We also recently found a vulnerability in ChatGPT Atlas, which was conceptually similar. I'm not going to talk about it in detail because it's still like pending disclosure. So please don't try to hack anyone. But anyway, like if you open up Comet browser, you realize that, okay, like it's actually, so I mean, it is based on Chromium, and under the hood, like basically how it works is just that, like it is Chromium but with an extension called the Comet agent that the user can't like get rid of, and all of the core functionality comes down to this extension which runs a background script, and it has, like as you can see, a bunch of permissions, access to the debugger backend, read and change any of your like website DOM elements and stuff like that. So it's a very permissive extension, which, you know, like if you were to publish this extension in the Chrome extension store, like it probably maybe wouldn't even be accepted because of like all of the permissions that it requires. But obviously, like this is sort of what you need in order to create the functionality that they had. So then you have this Comet browser sidecar, which is part of the UI in the browser, and basically how this works is that yeah, you have the classic like ChatGPT-esque interface where the user would enter their input, and this user input like sort of goes into this is sent to the Comet extension background script, which is part of that extension earlier, and that extension, because it has the permissions to control the browser via DevTools, what this background script does is that, well, it first communicates with the, like Perplexity is running an agent server somewhere on perplexity.ai. There's a WebSocket connection between this background script and Perplexity server. Perplexity server would then do the simple task of taking the messages, and I mean, like they might send it off to ChatGPT or like the GPT-5 model, or like they might have some of their own models. Actually, like I think recently they said they have some of their own models. They get the result from the LLM, and then like the result might be some, for instance, like tool calls. So the tool call might say, navigate to this website, or like click this DOM element. And so the tool call gets received by the background script, and the background script can control the browser and basically like execute these tool calls via the DevTools. And so this is the whole flow. So let's say if I want to send an email, I tell Perplexity, hi, I want to send an email to Marcus at Hacktron AI. And so it basically says, okay, like it sends this send email message, like what I said, right, to the Comet agent extension. And then the background script is listening for messages from Perplexity.ai. It also can send messages to Perplexity.ai. And it sends this message to send an email to Marcus, to this Perplexity.ai server. And so now the Perplexity.ai server says, okay, maybe it says something like navigate to gmail.com. And so it goes through this message router, and because the extension obviously has the permissions that I showed earlier, like it can open new tabs, it can open tabs to arbitrary URLs, so it opens a tab to gmail.com. And then maybe after opening the tab to gmail.com, the extension says again, okay, this is the observation from from executing this tool call. I have now opened a new tab, and then maybe the agent server says, okay, now read the contents of this new tab. And that's sort of like the basic idea of like how this agent flow works. And so if you pause for a moment and you think about like in this entire flow, what is one point at which like an attacker can most plausibly get in and like break this whole like sort of security boundary? Actually, if you were to find a vulnerability or somehow compromise one of the subdomains of Perplexity.ai, if you find any kind of cross-site scripting vulnerability on any subdomain of Perplexity.ai, everything below this is no longer trusted, because then because the extension trusts any messages that come from any wildcard subdomain of Perplexity.ai. And so like that's exactly what we did. So we set out the goal of like, okay, if you have an XSS on any of these domains, you can have a universal XSS on the Comet browser, which means that you can now take an XSS which has a I guess like impact constraint to that particular subdomain and leverage that into basically the entire internet, right? Like you if you have an XSS on login.perplexity.ai, you can only read cookies from that domain. You can only read responses from that domain. You can only send authenticated requests on that domain. But if you have this universal XSS, then you can like I guess do that, but for every website, and that's quite bad. So fortunately, or unfortunately, there are many subdomains on Perplexity.ai. So for instance, like community.perplexity.ai, that's like a forum, and then there's like also this fellowship thing, which I think is like some kind of like student ambassador program or something. And unfortunately, there's like this very, I guess, common thing that we see, which is like a redirection XSS vulnerability, which is like it's pretty basic. It's that like when you either log in or like log out from a website, usually there's like this feature where maybe when you log in, it brings you back to where you were previously, or like when you log out, it brings you to somewhere that you were previously. And there's this quirk where, you know, like if you have a JavaScript protocol URL and you navigate to that JavaScript protocol URL, it executes JavaScript on the domain that navigated to that JavaScript URL. And so then you have like permissions on that domain. There's a slight problem, like we have, they had a Cloudflare firewall, but there's nothing that some ingenuity as a hacker can't beat. I mean, you can figure out this by yourself later, but basically like it's like a two-step thing. Like first of all, you go to like a JavaScript URL that constructs a second payload, which then you put onto the site. But yeah, like end of the day, you have a cross-site scripting vulnerability on fellowship.perplexity.ai. So now you can execute arbitrary JavaScript from this domain. And as we said, because you can now send any messages through the Chrome API from this domain. And the extension is listening for these specific types of messages with this kind of I guess like with this format. So there's like a type, which is like the kind of like tool that you want to run. There's like the method name. There's arguments and stuff like that. So obviously there's like a, I mean, if you look at, I mean, so basically like we went to look at the minified JavaScript. Like it's quite annoying, but like with the help of AI, obviously, like I mean, I'll talk about like our CLI and like stuff like that later that we use internally. But with the help of AI, you can sort of make sense of it and try to find like where certain information is. And yeah, like there's a very interesting type called call to, which by the name you can probably guess like it has something to do with like calling tools that the AI is supposed to use. And you might imagine the tools, like I mentioned earlier, can be anything from like opening a page or like reading the contents of a page, which is like what the agent would need in order to do its job, right? And so let's look at like what kind of tool calls there are. So you can open a new browser tab, you can get the full page content, there's even one that literally says control browser, search web, stuff like that. So obviously like, yeah, the control browser is quite interesting. You can open new tabs. So first of all, you can open a tab that goes to any URL you want. So you might go to gmail.com. Then in the second step, you call the tool get content, which gets the DOM of the website that you navigated to. So if I navigated you to gmail.com, I can read all of your emails. Yeah, and then there's also even one action that's like start agent from Perplexity, which allows you to essentially like tell the agent what to do, and like basically like you could say like, oh, read mails and send the emails to like some other website. There's a nice video, I guess, like of showing like the exploit. So let's say if you go to so this is we are on Comet Browser. So let's say if you go to this URL that was vulnerable, this fellowship.perplexity.ai. So now you have navigated to this URL, which then like runs this JavaScript payload. The first thing it did was it opened, it can read. Oh yeah, I didn't mention it can read like local files as well if you use the file : / protocol. And so yeah, you can literally read any files on the computer. You can go to the guy's Gmail account. And there's also like, I think in this video we showed that you could change the guy's name on Google without them knowing. So it changed the full name to Pwn, some Pwn and the original name. Yeah. So it changed the guy's Google username without them knowing. Yeah. And so like this is like I mean like honestly, like when you think about it, like this is like I guess like a AI like vulnerability, but then like at the end of the day, like it is just a very classic like application security vulnerability. Like I think like when you sort of think about like the new attack surfaces that AI introduces, it's really more or less just that like I mean you're sort of just shifting the trust boundary, right? You're shifting the trust boundary to the input of the LLM rather than like I mean originally like you would say that user inputs are not trusted, but now like I think like LLM outputs shouldn't be trusted either. But that's like I mean how do you address that? That's like a different question, but you know like I think like the fundamental issues are still the same. There's also something we found in Cluely. I don't know if you all know about Cluely, like the cheating software. But like they basically like advertise it as like they're helping you to cheat in interviews. So we found a vulnerability in Cluely where if you were to open my interview website, I would be able to see everything that's happening on your computer, like as the interviewer, like which kind of defeats the whole purpose of their software. So how it works is that, okay, so like we go to this website, there's an interview task, and this is like, so their app is an Electron app, and basically how Electron apps work generally is that there's a renderer process. So the renderer process is the one that's displaying that top level overlay there. And then there's like the background process. So kind of similar to how the Chrome extension thing works. There's like two different, there's like presentation layer, and then there's like the background process that's sort of like controlling the actual like functionality. So the presentation layer, the render process there is the one at the top. And unfortunately, because they basically render the LLM output as Markdown, which is fine, except for the fact that the LLM is responding to is obviously responding to the interview question, which means that if the interview question gets it to render Markdown in a way that's like, so here we got it to render like a link to our own website, and when they click the link to our own website, so how Electron works is that the renderer process obviously needs some way to send messages to the background process in order for the background process to know what it wants to do. So the renderer process has this thing called IPC, inter-process communication, which allows the renderer process and the background process to exchange messages. And so if the user clicks on a link and goes to our website, obviously now our website, I can write any code that communicates with the background process through the IPC, right? So like I could write JavaScript code that takes a screenshot or does a recording because they expose the tools through the IPC. Yeah, so like we can even open a random like YouTube page. And like the other thing was that they were using an outdated Chromium version, which meant that there was a remote code execution exploit as well. Yeah, so like we turned their product into malware, and they ignored us. But anyway, like this is my point. Like there's this almost like evolution of software in general. So like software 1.0, I guess like you could think about it as like, oh, it's like kind of like a very like deterministic, like, oh, if, else, whatever, right? So when you want to break software 1.0, like it's kind of like, oh, can I break the rules? Can I break the business logic that the person was intending? Might have missed some edge case, right? When they were writing all of these like checks. And then software 2.0, I guess like you could think about this as like, so when Tesla was doing their self-driving cars, at first it was like a lot of heuristics, and they were writing a lot of heuristics and like algorithms in C++, and then like they started replacing parts of those software with ML models that were trained to do specific things. For instance, recognizing stop signs. So software 2.0 means that, okay, now we're replacing all of these features with like ML models, and it becomes like a bit easier somewhat or I guess like because these things are less robust. Robust means that, okay, can you like think about all of the possible edge cases? You can't possibly think of the space of all like possible stop sign inputs, stop sign images, for example. So basically this led to this thing where you could perturb the image by a little bit, observe whether the gradient is going up or down, and then like force it in the right direction, so that it gets like misclassified. And then now software 3.0, which is like LLMs, it's a lot more easier to persuade the model to do what you want, because first of all, it's not deterministic. You run the same thing again, you get two different results. So first time you fail, you just try again, right? And also like it's in plain English, like you don't even need to bother about like, I mean, at least like software 2.0, you need to have some level of understanding of like, like what a gradient means. But you can just like persuade the model to do what you want in plain English. So this is a very hard problem, particularly because we want AI agents to have autonomy. If not, they are kind of useless. But then this means that the systems become more fragile. And this is the classic case of the confused deputy problem. Like what this problem means is that, So I, as an attacker, I am system C. I want to do something that I don't have permission to. So I need to ask someone else, system B, who system B is the deputy. In this case, like it's the AI, is the LLM. But the LLM obviously like is like dumb. It's not like a person. It's not like a actor in this like model. But then like it has like I mean it can ask system A for permission to do something else, which is like completely out of the picture. So like I am the attacker. Like I control some external website, but I can get the LLM to ask the browser agent the browser extension to do something. And like that breaks the trust boundary. But at the end of the day, it's like sort of very old like abstract lessons. Like it's just like injection attacks and stuff like that, and like whether you want to trust inputs or not. And so like at the end of the day, like I don't think it's that different. It's just that like like everyone is vibe coding nowadays, and like that's sort of making people realize security is more important, I guess, and that's like the only difference that I kind of see. And you want to like start thinking about security from day one. So the second part of this is like, okay, like a little bit about like sort of the journey that we have come from like trying to make AI agents that do security work. This is sort of what we've been working on for the past 6 months, and like there's been a lot of like pivots and like, iterations in the middle. But there were some general lessons that we have gained. So let's say like we want to automate finding this basic bug. So if you guys know, like a while ago, this dating app called T was like hacked. Like it wasn't really a hack. Like it was more of like they just had a public access. They just stored everyone's images and like whatever into like a Firebase like a storage instance, and then like they just allowed anyone on the internet to read it. So it wasn't really a hack. It was just like the devs are bad. But how do you automate finding this, right? Like obviously like, there's a lot of tools on the market. There's SamGrab, CodeQL. These are like commercial tools on the market that do like static code analysis. OpenGrab is the open source version of SamGrab. But you realize that actually they don't support like these Firebase configs. Like they say, oh, we'll find vulnerabilities in like JavaScript code and in Python code. But then when it comes to like simple things like this, like it doesn't work. So you could also just write a regex and you just use grep. But then like that's not ideal either, because then like how do you maintain, like are you gonna write like 1,000 different regex rules? But if you actually, let's say like I took this vulnerable config and I gave it to an LLM and I said, so here's an example of something that's vulnerable for a Firebase config. Does it exist on this different code base? The LLM can actually catch very messy, like sort of subtle, or rather like variations of vulnerabilities. And the best thing is that you can pull surrounding context into it. And actually like this is, I think, like the fuzziness of LLMs actually like is something that almost like directly addresses the limitations of static analysis tools that we have seen like previously on the market, because they are too rigid, and people ended up writing like custom rules for them. So here's what we believe. We believe that 90% of software vulnerabilities are essentially like variations of repeated vulnerabilities. And I guess like when it comes to the best security researchers, like a lot of these things are sort of tested in their heads. Like they know, like if you ask a pen tester, here's an app, they kind of in their head have a step 1, I'm going to check this, step 2, I'm going to check this, step 3, I'm going to check this, which they don't really say out loud, but they kind of have the intuition there. And so our goal here is then to distill this knowledge into LLM agents that can retrieve these like things that are in their head dynamically into the context. And that's why like building with like the best security researchers are the most important. But I guess like, yeah, there's like 3 lessons that I generally like just want to share about this. So like just now I compared like an LLM to like traditional like SaaS tools on the market. So like I'll just give like a high level overview of like what these SaaS tools generally do. So in general, they take a code base, they parse each source file and generate an abstract syntax tree for each source file. So basically this just means like it gets something on the right on the right there where you can see it takes the syntax of that file, and it constructs a tree based on like, okay, like this is a function, these are arguments, blah blah blah. So an AST is great, but it doesn't resolve like, I mean, each file has its own AST. It doesn't resolve like cross-file references just yet. So it transforms the ASTs into a control flow graph. So now you have like the full like this file has this method, and then another file calls this method, blah blah blah, and like you can see like the actual control flow where like, oh, like if this condition is true, it goes to here, and then like this calls this function from a different module and stuff like that. So this is great, and this is sort of the basis of what we call taint tracking. So taint tracking basically just means that we are trying to answer the question of does any untrusted input ever reach a dangerous sink? So an untrusted input might be an HTTP header, it might be like a request parameter. A dangerous sink might be something like an eval or like a SQL query. And so data flow analysis uses the control flow graphs, and it starts by looking at potentially like untrusted sources. So we call all of these, the set of all possible user inputs like the sources, and then we have some functions that we don't want them to ever reach, and we call those sinks. And so we are essentially then just saying in this control flow graph, can the source flow to the sink? And then there's like some subtleties in the middle where obviously if you encounter a sanitizer, that stops the taint propagation. And so essentially like you are just saying, yeah, like you almost think about this as like starting from like a few nodes, they are like sort of polluting the other nodes, and then like if it reaches like a sanitizer, it stops the pollution there. But now you have this thing that's like sort of polluting downwards. Does it ever reach a dangerous sink? But in practice, so like this is what tools like CodeQL and SandGrab do. In practice, there are quite a few limitations in doing this in like sort of real life because first of all, like if you just want to solve this problem for C++, well, maybe. But then if you want to generalize this, then like, okay, like a lot of these possible sources and sinks are framework and language specific, right? If you use Next.js, there's a very different sort of, that they are meant, like navigation in Next.js is different from navigation in Vue, for instance. Like router.push doesn't exist in other frameworks. Sanitizers are meant to stop taint, but there are many sort of edge cases. So like maybe your SAST knows about DOM Purify. Does it know about like the 1,000 different like HTTP sanitizers, HTML sanitizers there are? So security engineers end up manually extending rules based on like what sanitizers and what frameworks they use in their own code base. This was like something that like wasted like a lot of time on like like my previous stints. But you know, like as I alluded to earlier, like the sort of fuzziness of LLMs is something that really helps here because the main problem here is that these rules are too rigid, right? You can write one rule for your particular code base, it will work for your particular code base, but the moment, let's say, you change to a different library for sanitization, or like you introduce like some new thing that's like that isn't covered by your rules, then it stops working, right? So so instead of thinking about like, oh, we want to have a SAST that is enhanced by LLMs, like actually the LLM can actually act like a SAST. So like now you have these AST and CFG, you have the control flow graph. These algorithms are pretty straightforward. But once you have these graphs, why not just take the LLM, ask it to traverse the graph like a SAST. So you say, you give the LLM, okay, like these are the inputs, and you challenge it, okay, like now your task is to find a path from the source to the sink. Can you find a path from the source to the sink? If you can, then like, and you just need to give it the right tools to traverse this graph. But then like obviously the graphs can be massive. Where do you start? So how do you know which inputs are sources are vulnerable sources, for instance? And how do you know which things to look for? So, like if you want to generalize this for any framework or language, you can start gathering some general information about this code base. We have what we call a knowledge base, where we try our best to have most of the common frameworks and languages, but if not, there's also like sort of web search and stuff like that. So you can like retrieve relevant things. But of course, the knowledge base is not going to have everything. And so like this is where having users is a good thing, because so I say synthetic data here. Can we generate quote unquote synthetic data? I mean, like, so essentially this is the idea of if the system finds an instance of a vulnerability that the knowledge base doesn't know about, but it is but the validation harness says that this is a correct vulnerability that you can actually exploit, then clearly this is something that we are missing from our knowledge base, and we could synthetically generate a new rule using an LLM and add that to our knowledge base. So this is how, like, as you continue to use this for security research and pen testing, like it's sort of the knowledge base gets more complete. The second lesson is to eval everything. So like one thing that we've learned is that actually cheap, weaker models can be better than expensive models. So like let's say you have Gemini 2.5 Pro and Gemini 2.5 Flash, or like ChatGPT 5 and ChatGPT 5 Mini. Maybe the first model succeeds 70% of the time. The second model is much more accurate, it succeeds 90% of the time. But you can actually just run the first model 3 times if you don't really care about latency and like just get 97% of the time right. Or you can alloy the models. You can say if the first model doesn't perform well, if the first model errors out, or if the first model fails the first time, I swap to a more expensive model for this particular task. So for this particular step of the I guess, so we use line graph, so like you would call it like the graph. This particular step of the execution, like we swap in a more expensive model just to get past this hurdle. But you have to make sure that the ground truth in your evaluations are correct, of course. So this is an eval that we did on like basically like we had this Ruby code base, which Ruby on Rails code base, which had a SQL injection vulnerability. And in our evaluations, we said that the model was supposed to find the API path that was handled by this particular route. And our ground truth answer was wrong. So we said that the model only passes if, sorry, like the evaluation only passes if it gives the answer /API /internal /UTM underscore links. But the correct answer was actually without the /API at the start. I don't know why, like I think like we just sort of assume that like the /API thing was like, because I think like a lot of the other routes had /API at the start, but that route didn't. And so like we just assumed that was the correct answer, but actually like we spent a lot of time figuring out why GPT-5 was doing worse than Gemini 2.5 Pro when actually it was better, and like our answer was wrong. And the third lesson is that I mean like we obviously like as like a CS student venturing into like entrepreneurship and like business and whatever, like sort of the security market is a market for lemons. So like buyers don't know about the quality of the product until they get hacked. But the sellers do. I mean, we do our own internal evals. Maybe our competitors don't. Nobody knows. But everyone is still trying to tell everyone else what they should and shouldn't buy, right? So like the main problem here is that let's say I'm a buyer, I'm a CISO, I want to buy a security product. Be it like even like an antivirus or something, right? Like I don't actually know whether your antivirus is good until it fails to catch a virus that's on my computer. And so this is like the classic like market failure, right? Like the buyers don't know what they are buying. The sellers know, and like they can basically like charge whatever they want. and nobody knows anything at the end of the day. So we originally started as a replacement for Sneak, SamGrab, CodeQL, like all of the SaaS tools that we were talking about earlier. There were several issues, like a lot, like basically like the business model for like all of these tools is that, okay, like we are going to charge you by how many developers you have on your GitHub repo per month, and then like we're going to run a scan for every pull request. There were several issues. So like first of all being that like we are a startup, like like enterprise customers who are SOC 2 certified want all of their vendors to also be SOC 2 certified, but we only get our certification in December. I'm rushing for them to do it next month, but hopefully. But like this is still going to be a problem. But the main problem is that the information asymmetry, like the market for lemons thing that I talked about, means that it's always going to be harder for startups to sell top down. So how do you solve the trust boundary, right? How do you solve the trust problem? You actually, yeah, if you take a page out of like other like dev tool products, like actually there's like this very strong like sort of thing that you can do, which is like do bottom up adoption from like the devs and security engineers. So if you actually have a tool that makes their lives easier, and like everyone starts using them, it's much easier to convert that into like okay, like now we have like an enterprise plan. Like I mean, Cursor now has an enterprise plan also, right? So like now we have an enterprise plan which allows all of your devs to use this thing, and it integrates into your like SSO, and like it does like makes like your organization's life easier at the same time. So that's actually like much easier than like going and selling straight to the CISOs, because no one trusts you at the start. So we're releasing a CLI that helps security engineers and pen testers to do their offensive security work more efficiently. This is after like pivoting away from like the whole original idea. But yeah, like this is like something that's like Cloud Code but for security, something like that. And you can join the waitlist there. But that's that's the end of my talk. I hope you enjoyed it. Yeah. Oh, confused deputy problem.
Was this an example of what happened with Comet?
Yeah, so like this is a illustration of like what the confused deputy problem is in general. So like there are many instances of the confused deputy problem. What happened with Comet was one of them. So here system C is the attacker. The system C wants to do X, but it doesn't have the permission by itself. So it goes to like a sort of like a middleman, which is like this system B. But system B is able to talk to system A and get permission to do that thing. The thing is that like the confused deputy here doesn't know that system C is not supposed to be able to do that thing. It just knows that I have been granted permission to do this thing. I don't know that the person asking me to do it doesn't have permission to. So here, I as the what's it called, the like I as the extension background script thingy has permission to view the users like view the DOM of that website. I don't know that the website that the attacker controls shouldn't be able to do that, because that guy has obviously like impersonated the Perplexity.ai domain. So yeah, like hope that makes sense.
Because the LLM's job is just to understand the prompt,
Yeah.
make sense of it, and use the relevant labels. So it does not check if the prompt itself is coming from an attacker. That's what it's
Yeah. Yeah.
One more thing. Can you go to the next slide? Next one. Yeah. What is SAST?
Oh, static. So, static analysis security testing, something like that. Like basically like a security testing tool that does static analysis.
Have any other questions?
How do you deal with like multi-repo like code bases?
Yeah. So yeah, this is something that this is also like something that we encountered when we were trying to do the GitHub integration thing. Was that yeah, like if you were to do it that way, then you can't really do multi-repo. Like the so I mean, in general, it is a difficult problem. But then, like, if you were to run our CLI, for instance, in like a in like the parent repo of those two repos, then like it kind of works. But yeah, like, I mean, but you still have to say that oh, this particular like or rather like this is a front end repo, and like all of the all of the inputs from the user in this repo that goes into this particular like HTTP what do you call it, like this particular HTTP request that the front end repo calls has to flow into the backend input. That's like much harder to solve than just like pure control flow graphs. But that's something that like, well, the good thing is then like compared to SAS tools, the LLM understands this context, and you can just tell it. You can, but it obviously it goes back to the first part where we first do some recon on the code base and understand the context, like the business logic and like the context of the code base. Yeah.
How do you like overcome the context saying for every large code bases?
Yeah. So going back to the knowledge base. So like I guess like you could think about it as like so you are so we obviously like wouldn't have like every file whatever in the context at the same time. Like there are certain abstractions that you can make. So for instance, like I mean the most basic step you can take is just summarization. But then like there's like we sort of think about this like especially with the knowledge base, you can sort of think about this abstraction as like almost kind of similar to like virtual and physical memory. So like you have like this fixed context window that you have to manage. At any point in time in this context window, I want to have some level of like the past conversation history and like what happened before, but I also want to have like the relevant information from the knowledge base at some like in some part of this context window, and then like finally like I want to have the code that I'm currently looking at. So managing this like fixed context window is kind of like it's kind of like the similar logic of like paging in and out, like the context, like the knowledge base part you can replace. The past events part you can summarize. And then like the current like file thing, you can obviously like you can read like parts of a file at a time. Like so if like a 10,000 line like file, you obviously don't read everything. And then obviously like if you are doing like the taint analysis like I mentioned earlier, you don't actually need to read the whole file. So like you just follow the references, right? So like if I say yeah, so if I say if I'm looking at the first part where I say like the request is an input, I follow the references of that variable, and I find that there's a reference to that variable in this other file, and so I only need to look at that reference, if that makes sense. Yeah. And of course like maybe like 10, 20 lines surrounding it. Yeah.
How do you solve for false context?
Yeah, yeah. So this is a hard problem. So like I think like the first step you can do if you don't have like a dynamic like execution environment is that at the first step like getting the LLM to even like very basic things like so even very basic things like forcing the LLM to explain the full the full flow of the taint, and then like getting the LLM to write like an actual proof of concept exploit, even though you're not giving it an actual environment to run it in. We've seen that with like models like GPT-5, like that sort of like helps in some way, yeah, to sort of make it like a bit less like dumb. But like also, I mean, we do have this thing where I mean, if you were to give it an environment that is representative of the code base, like we have tools for the LLM to like test their exploits. Like this is currently only limited to web applications, but yeah, like that would be like I mean like that is definitely like a almost like a foolproof like way to verify. But without that, like yeah, like you just want to make sure that your taint tracking is like very good, yeah.
Okay, maybe one last question. Yeah.
I'm just wondering, like this as a general or maybe in the future kind of scenario, because you mentioned that there's a lot of AI building apps now, like Lovable, for example, and now you're trying to build one for security. Right? Do you think it's possible for Hacktron agent, for example, to communicate or to be embedded as part of Lovable and then communicate with like AI builder and then bounce these things off as people build with this English?
Yeah, so I mean it's it's interesting you mentioned Lovable. So like I was actually in Stockholm like a few weeks ago, and we actually were at Lovable's office discussing something similar. I think the main yeah, I think here the main trade-off, like I think in general would just be like I mean like you can have like a add-on thing where you say, okay, like now you have built this thing with Lovable, like pay like extra like $20 to like subscribe to like this security thing which is embedded into the Lovable app, but it's actually provided by someone else. Like I mean, I don't know how many people would pay that extra $20 just because like the main users of Lovable are like, I mean, like I don't know how many of you use Lovable, but like I feel like at least to me it seems that like the main users of Lovable are like non-technical people who probably wouldn't even start thinking about security. But like I might be wrong. Like I think at least from my perspective, I don't think like I mean. My impression is just that like Lovable doesn't really care that much about security, just because like from I mean like from they only really they have like a very basic like security testing part of their thing, but like they only did that after someone posted on Twitter and got like a lot of traction for saying they hacked some like Lovable websites. Like I think that there is a future there, but I think probably what would be the most valuable is if someone could make sure that in maybe like the post-training process of like OpenAI's models, or like any of these like, or probably maybe not OpenAI, but like maybe some of the open source models, in maybe the post-training process or somewhere along the line of before the code is actually outputted, like you add some level of like security there. That's obviously going to be very hard, and like I think like eventually someone is going to be the macaw of like security or something, where they have like a bunch of like security like data, and they sell to like the frontier labs to add that part into their thing. I think that's at least my perception of like how this thing will play out in the next like 5 years. But yeah, like that's where my thoughts are at. Yeah.
Okay, that's all the time that we have. Feel free to approach him later for more questions. Let's thank him for
All right.
his talk.
Thank you.